Welcome to Mimi's Math channel. Today I will demonstrate how to factor using Desmos. So the first example, we're going to factor a quadratic. Once you type in your function or your equation, it will go ahead and graph for you. What you're looking for is on your x-axis where your y's are 0. Those are called your x-intercepts, zeros, solutions, or roots. It all means the same thing. So if I'm trying to put this in factored form, these are my zeros. However, I don't want to use a decimal in factored form. I'm going to go ahead and convert this to a fraction, which I don't want to use that either in factored form, but it is going to help me to factor. So I'm going to type in negative 0.5, and next to it, you will see that there's a fraction icon. So if you click that, the equivalent fraction is negative 1/2. So that's going to be useful. We're going to go and we're going to type in the other zero that was given, which is 0.75. If you don't know this as a fraction, like I said, just click this button, and that's going to be positive 3/4. Now pay attention to your signs because we're going to have to change them. This is what x currently is. So what that looks like is x is going to be equal to negative 1/2 in one case, and x is equal to positive 3/4 in the other case. I'm going to move everything over to the side where the x is, but when you move anything over, you always change the sign. And when I'm factoring it, you're going to see parentheses. So I'm going to have x plus 1/2. But remember, I said we don't want to leave that fraction in there. That's just our starting point. And that's positive 1/2, not negative, because I changed the sign when I moved it over. And then on the next one, it's negative 3/4 because, again, we changed the sign. This is not how you leave it. What you want to do is you actually want to see if you can further simplify this fraction that's shown over here. If you cannot further simplify that fraction, then you're going to have to take the denominator of the fraction and you're going to have to move it in front of your x. This 2, I would move it in front of my x. So I would now have 2x plus 1. Over here, I'm going to take the 4 and I'm going to move it in front of my x. So I have 4x minus 3. That's my factored form. Let's just double check it to make sure. So we're going to go back into Desmos and we're going to type that information in. If it's correct, it's going to match the graph that's already there. So we said 2x plus 1 times the quantity of 4x minus 3. And see how it lays exactly on top of the original one? But if you had typed in the wrong signs, like a minus here and a plus here, because that's what was initially given, you'll notice that that's incorrect. If it is already a negative on the graph, then when you put it in factor form, it's going to turn into a positive, and vice versa. If it's already a positive, it's going to turn into a negative. Now I want to write a polynomial function in factored form when I'm already given a graph. I see that my end behavior for my second arrow is going down, so therefore I have a negative sign, and it started off going from the top. That's just telling us, like, as x approaches negative infinity, this is going to be a positive infinity. This does not dictate the leading coefficient. The second arrow dictates the leading coefficient. So if it's pointing down, it's negative. If it's pointing up, then it's going to be understood to be positive. X means that I have a point at 0. This one, it says x plus 2 because I see that one of my zeros is negative 2. Well, I want to go from this form to the factored form, so I have to change the sign. If I were to put negative 2 in for x, this would equal 0, and that's what I want to happen. So I always write the opposite sign. Well, where did this degree come from? It came from the multiplicity. This is a snake or a bend, which represents a multiplicity of 3. This is straight through multiplicity of 1. So therefore, that's why the exponent for x was just 1. Here, this is a bounce. For the bounce, that's going to be a multiplicity of 2. So instead of positive 1, you're going to have a factor form of x minus 1 raised to the second power, because that's my multiplicity. And then this one is positive 2, but it's straight through. So x is going to be minus 2 raised to the first power. Multiplicity or zeros are only affected by what's on my x-axis. This is not a bounce, nor is this one. And then it asks you, what degree is this polynomial? Well, there's multiple ways that you can look at it. Count your multiplicities, that will tell you. So 3 plus 1 is 4, plus 2 is 6, plus 1 is 7. So this is the 7th degree. And the way that you would see it is the highest exponent will be x to the 7th power. Another way you could have did it is just count it in factored form. So x to the first power, 1 plus 3 is 4, 4 plus 2 is 6, 6 plus 1 is 7. We know that it's an odd number because the arrows are pointing in different directions. Or you could have just counted it from your zeros, but you just have to pay attention to the multiplicity. So this is 3, 4, 5, 6, 7. You could have counted from the turns and then added 1. So I'm turning once, twice, 3 times, 4 times, 5 times, 6. 6 is an even number. I have to add 1. That will make it 7. This is an end behavior. And then here's your other one. You can barely see it. It's an odd graph. For example 3, we are given zeros of -1, multiplicity 2, 0 multiplicity 2, root 5, and we're asked to write a polynomial function in factored form. So I went ahead and wrote my x's out. X is -1 with the multiplicity of 2. X is 0 with the multiplicity of 2. X is root 5. I have to know the irrational root theorem, which tells me that if they're giving me positive root 5, I have to account for the conjugate of negative root 5. That is only for irrational roots and also for imaginary numbers. When you are putting this in factor form, it's going to look like this. I see that both arrows are pointing up, so that means it's going to be an even degree. So when I'm asked about the degree, I'm looking for an even number. And in terms of my zeros, x-intercept solutions or roots, it's whatever is on my x, where the graph crosses my x-axis. So -1 would be +1 in the parentheses. However, there's a bounce there, so it's going to be raised to the 2nd power. 0 has a bounce as well, so it's raised to the 2nd power, but it's only shown with an x. It's not x plus 0, not x minus 0. And it goes after the equal sign. That's where you want to put it. Notice that I don't have a negative sign after the equal sign because my end behavior for the second arrow is pointing upward. So that's why I know my leading coefficient is going to be positive. Now I'm looking here and I see decimals. What would I have to put in the place of x to make this equal 0? So it's going to have to be the opposite sign. It would have to be -√5. So let's just test this. If I had negative, I can type in SQRT for the square root, which is going to actually be equivalent. So I know that that's correct. The other way is to hit the keyboard function and then press the square root symbol and now type in 5. And it gives me this as my actual equivalent decimal. So I know that if I'm looking at all of these zeros, this is equivalent to what I actually have for my factored form. If I'm looking at my degree, is 2 plus 2, which is 4, plus 1, 5, plus another one, 6, which makes sense because it's even. The degree of this polynomial is 6. And if I were looking at it in standard form, it would be the highest degree is raised to the 6th power. In the last example, if I am given zeros, -3, -2 plus root 7, I am asked to write a polynomial function in factored form. Whenever I move anything over from one side to the other, I change the sign. So I'm putting this in factored form. So that's going to be x plus 3. For the next one, all of this is being moved over as an expression. So if I move over -2, that's going to be x plus 2. Don't forget the x. Then if I move this one over, that's going to be -√7. Now I go to the next one, do the same thing. Well, guess what? The -2 still is x plus 2. I'm not changing anything with the real part. It's only the irrational part that I'm changing. But this time, this now becomes +√7. So this is what it would look like if I were writing it as an equation with y equals or function. I could put f of x. If I wanted to know the degree of this polynomial, just looking at the roots, I can just count the degrees that are shown here. And so I see that this is raised to the 1st power. It's understood. This one as well. And so is this. So if I added all of them together, I'm going to get the highest degree is going to be the 3rd degree. So in standard form, it will be something like x to the 3rd power. So this is what it looks like. And as I click on this, I see I have 3 real solutions. And I know it's an odd degree because the arrows are going in different directions. But my last arrow is going up. So therefore, I know I'm going to have a positive leading coefficient. Another way that is acceptable for factoring is x plus 3 times x squared plus 4x minus 3. And like I said, if I'm doing it correctly, it's going to overlay what's already there. So if you want to know how I went from this form to this form because they mean the same thing. I just multiplied these last two together. And I did show you that in another video called Fundamental Theorem of Algebra. So if you just really want to know, you can go and watch that video. So that is it for this video. Thumbs up, subscribe, have an awesome day.